whichever ones you guys want to go over. So which ones were the 4? Okay. Any other? The first one, okay. And the second one, okay. Third one? Yeah. I just remember that.
Number 2.
I'm writing this over. Great.
No. He was on my bus. He actually did.
Alright, so we're just going to go through all of them. That's fine. So for number 1, to solve this algebraically, pick something to move. Let's say you got rid of the 4x, subtract it on both sides. Then by default, I'd have to move the 12 over by adding. Right there. So that the 4's cancel, the 12's cancel, and I'm left with 2 equals 2x, and divide both sides by 2. So that x equals 2. If you did it the opposite way, where you moved 10 and 6x, then you would get a negative and a negative, and it would still get a positive 1. Questions on that? Did you move 10 and 6? Okay, so then if you move 10, you end up with a negative 2. If you move 6, you'd end up with a negative 2, so you'd have negative 2 equals negative 2x. And then you'd be dividing by negative 2. And you still have 4 and 10. Oh, but you can't do that. Right, you can't move the same things on the same side.
Why can't you do 10 and 12?
Move the 10 to 12 and combine it. Then move the 2 back after you combine it. If I move 10, then I'm automatically adding it to this. I can't move 12 at the same time. And move the 12 to the other side. Add it to the other side.
Add it to 10.
Other questions on that one? Okay, number 2. Similar, but had more fractions. We can distribute the negative 3 to both of those, either algebraically or using your calculator. So we get 1/2 x minus 7 equals 5 minus, this would be 15, negative 15 over 6. Divide both of those by 3 to get 5 over 2x. And then negative 3 times negative 2 would be a positive 6. Then we could combine like terms on the same side, yes.
Can you add like a 5 minus first and then multiply?
Because this is right next to the parentheses, so that's being multiplied. I can't combine those two.
So what do we do with the 5 after we multiply?
5 and 6, we combine them, add them. And then you can start to move things to opposite sides. So let's say we added 5 halves.
Did you combine like 2 and 2?
The 5 and the 6, yes. And if I'm moving 5 halves to the left, I'm going to add 7 to the right. So that I could add these two fractions. They have the same denominator. So I would just add the numerators, 1 and 5, to get 6. So that would be 6 over 2, which simplifies to just 3. And then this would be 18. And then we could divide both sides by 3. Questions on that one? Yes.
I got like 0.156. I don't know where I messed up.
Subtracted this 5 over here. To get that 8.
Uh-huh.
But then you did something here to get this. And we should have been
I
adding.
think I multiplied
You
these.
should have twice.
Oh, you can't?
You have to move it back to the other side. Other questions on that one? 3, he solved this equation already, so you don't need to solve. Then it says, what does Andre's work show us about the type of solution? So at the end, you get 2 equals 0. What type of solution is that?
No solution.
No solution, thank you. How do you know the variables canceled and it's not a true statement, or 0 doesn't equal 2? Whatever variety of that you would like to write that. Yes. Okay, and then in number 4, you start to solve this, but then you kind of change directions. So, let's say I go ahead and I start solving this like normal. We get negative 8x minus 4 equals 2, sorry. 8x minus 2. Then the question says, this is going to give me an infinitely many solutions, which means the sides should be equal. They should be the same. Well, the negative 2 part is already the same. So if this 1/2 k became something that was a negative 8, I could set those equal to each other and solve for k by multiplying both sides by 2. So if I were to put that back in, 1/2 times negative 16 would give me that negative 8, and then they'd be the same on both sides. Questions on that one?
It's not about that, but is it possible to put a variable on the calculator?
Yes. Yes.
Where do you put 2?
This 2?
Yeah.
So to undo this, you could either divide both sides by this 1/2, but that gets hectic, or take it and flip it and multiply on both sides. Multiply by the reciprocal. So that's the same thing as dividing by the fractions, but we want to avoid dividing by the fractions. Other questions? Okay.
I didn't get it. Like, I don't know how you did that.
Did which part?
Like the second part.
This part?
Yeah.
Like the 2's or this part?
Yeah. Like, so negative 2 and negative 2 are the same, right?
Mm-hmm.
For those, and then I don't know what you did with them.
So since this is infinitely many, that means both sides have to be the same, right? So since this is already the same, I don't need to worry about that part. But this part is not the same. So if I take not the x part, but just the negative 8 and just the 1/2 k, and solve for k, I could get what k is. This part was just solving for k.
But how do you solve for k?
So if I have some fraction like this, these two are multiplying. To get rid of that, you would usually divide, but that looks hectic. Trying to divide fractions all over the place. So instead, you multiply by the reciprocal, yes.
So you multiply by negative 8?
You multiply by 2.
But if we did divide by 1/2, would it be negative 4?
No. If you divide it by 4, yes, but you divide it by 1/2. It's the same as multiplying by the reciprocal. Other questions?
Negative 60 for that as well.
For k, yes.
Reciprocal.
Taking it, flipping it. Okay. Take out your notes from last class. So before we go on to today's, we gotta do just one word problem from that, so that we're all on the same page with that. If you need another one of those, I do have those. I have extras or things. Thank you. Okay, for this problem, it tells us to find the value of x so that the rectangles have the same area. first, how do we find the area of a rectangle? I heard someone say something, but I didn't know what it was. What were you saying? Nita. Multiply what?
Multiply the.
You need this water. Oh. Hold on 1 second. Go ahead. A rectangle?
A rectangle size. You multiply like size.
Yes. More specifically, length times width. Guys, stop talking. So the area of a rectangle is length times width. So now that we know that, did you find it? Do you need another one? Yeah. Okay. If we're finding the area of both of these rectangles, that would be the same as 12 times x, some length times width, and some 16 times x minus 2. But if they have the same area and I have to make some equation, I have to put something in between here. What would that be? Yes. The same area, they can be equal to each other. We have our equation, now we can solve. Go ahead and distribute the 16. What would our next step be? So instead of subtracting 12, let's subtract 16. That way we still have something on this side. If you subtract 12, you're going to end up with 0 and both things on this side. Then you're going to have to move something back. You would have created an extra step. Okay, and then our last step, divide. And what is x? -8. Positive 8. The negatives cancel. So if I were to put 8 in here, it didn't ask us to do this, but if it did say this, we could find the area by multiplying. What is that area?
So you multiply length times width.
No, is it 96? It is 96. If I had more information, I could put units. I don't really have those, so we'll just leave it as at 96. Yes.
So what did you do with the 32?
Nothing. I was just moving this and rewrote it.
Wait, how did you get 96?
Multiply 8 and 12 or 16 and 6.
Oh, because it's
Other questions there? Okay. So you'll have time to practice the others on your own, and then when you're doing those, if you have questions, you can ask me. Now switch to the other one. Okay, so first, notice that this standard starts with A2 instead of A1, or just A like it has been. This is one of the extensions that advanced algebra goes over that regular does not. Okay, so we are going to talk about how to solve absolute value equations, similar to regular equations, but slightly different. So first, make sure the absolute value expression is isolated. What does that mean? Get it by yourself, correct. Then we're going to set the inside part equal to a positive and negative number from the other side. We'll talk about that in a second. Then we're going to solve both equations. And then after we solve it, we're going to write our answer as a solution set. So similar to domain and range when we were writing it from a discrete graph, we're going to write it like this. X equals curly brackets whatever the first solution is, comma the second, least to greatest. If you don't have your calculator, you need that. Okay. So we're going to go through different examples so that you see how to solve these. Starting with number 1. So if there was something outside of the absolute value bars, in this case it's not, but if there was, we would do something with that and get that by itself. That's already done for us, so moving on. Then we're going to take the absolute value bars and drop them and set that inside, whatever is inside, equal to both a positive version of whatever this number is and a negative version. Because absolute value really measures distance. The absolute value of a negative is still a positive number. So if I walk forwards and then I walk backwards, I still walk the same amount of distance regardless. So because absolute value is measuring distance, you have to solve for both. Okay? And then if there were equations, we would have to solve it, but it's not. So then we would write this as a solution set, x equals least to greatest, negative 2, comma 2. If you get the same number, one's positive, one's negative, you could also write it like this. X equals, curly brackets. This symbol is called plus or minus. And then 2.
So that means negative or 2.
Yes. Questions on that so far?
So this is the plus and the minus.
Yes, it's saying both of them are solutions, yes. Okay, we're going to move on to 3. To number 3. I would really like it if I could not write like this, but we'll see. For this one, same process. If there were something outside of the absolute value, we would isolate and solve, but there's not. So we're going to drop the absolute value and set 5z equal to 40 and 5z equal to negative 40. And then we're going to solve both equations for z. How would we do that?
Putting in a number.
Not using brackets, what did you say?
Putting in a number.
Isaac? So divide both equations by 5 so that z equals what? Negative 8 and 8. I'm just going to do plus or minus 8, but you can put least to greatest if you so choose. Not all of them will have the same number. We'll get into some of those like that.
When writing the answer, do you have to put the little brackets on the outside?
Yes. Because this tells you this is the solution set. Both of these numbers fall within this solution. Okay. Other questions on that one before we go on?
Is that a plus?
This
Yeah.
is plus or minus. Okay, let's try number 5. Again, we would isolate the absolute value. That part's already done, so we can drop the absolute value bar, set the inside equal to a positive 8 and a negative 8. And solve for d. How would we do that? Isaac. Isaac, thank you. Okay, subtract 1 on both sides to both equations so that d equals what two values? 7 and negative 9. Not all of your answers will have the same two numbers. Yeah. Yes. So you would put those least to greatest, negative 9 and then 7. Questions on that? Okay. Now let's try number 7. No, because these aren't the same number. If they were the same number, yes. For number 7, similar. We don't have anything outside the absolute value, so we can go ahead and drop it. And set it equal to both a positive and a negative 34. If you forget to set it equal to a negative, you have now lost half of your answer and half of your work. So make sure you do that at the beginning. How would I start solving this? We could divide, but then we end up with fractions everywhere. We don't want that. Okay, and then last step. So that our two answers are what? 8 and negative 9. But in order, negative 9 and then 8. Yes. Sorry, this here. I'm trying to color code, but it's not letting me. So. Questions on that one? Are there any others on this side that we want to see do go over before we go on to the back? Okay, go on to the back. I mean, did you have one? No, okay. Alright, all the previous problems didn't actually have something outside of the absolute value bars. Now we do. So if there is the whatever outside of the absolute value bars, isolate it. So let's start with 9. Pretend that the absolute value bars, everything inside is like some x that you're trying to solve for. And you want to get rid of 2.
I know what? That's what you like. That's the point. That's it.
Pushing water is not bad. Water is healthy.
What were you about to ask? Okay, so for number 9, I start to say pretend that everything inside the absolute value bars is like some x. We're trying to solve for that. Leave that towards the end. So that means I'm going to focus on anything outside of the absolute value bars. Get rid of that by doing what? Subtracting on both sides, yes. Leave this in absolute value bars until you've gotten it by itself. Until there's nothing else around it. After that, then you can drop it. Do not drop it beforehand. So this would be similar to that first problem. There's nothing to solve, so I would set it equal to both of these. And our solution set would be that plus minus 10. Questions on that one? We're going to try number 11.
What does that say in the box? Isolate the what?
The absolute value bars. So for 11, how would we start solving that? Divide both sides by 6. can drop the absolute value bars, set that equal to a positive and negative 4, and then the solution will be the same. Yes.
5 divided by 6.
These two are next to each other, so they're multiplying.
Oh,
Only way to get rid of
it's
that is
reversed.
other questions on 11. Let's try 12. So similar, but now we actually have stuff inside. Disregard that until the end. What would be our first step? Divide. Just like 11, this is outside. They're next to each other. They're multiplying. So to get rid of that, you divide. Leave this in absolute value bars until you've gotten rid of the negative 2. Then you can drop it. And set it equal to the positive and the negative. And then solve. By doing what? It says Z. Subtract 3. What would our two answers be? Negative 10, positive 4. Questions on that one? Yes, Emmy, did you have a question?
Negative 10, that would be, oh, because we subtracted. And it adds.
Okay, look at 13, 14, 15, and 16. Which of those do we want to see, do, go over, have questions about? 13. Where'd the 4 come from? Negative 7 minus 3.
Oh.
Just 13. No other ones?
16.
Alright, so for 14 and 15, they're very similar to 16, so you should be able to do that based on what we do on 16. For 13, we gotta get rid of the 6. By doing what? Multiplying on both sides. So that those 6's cancel, and we're left with just the absolute value of 2w minus 4 equals 18. What's our next step? So hold that thought for 1 second. Mustafa, did you get your question answered?
It's not a 12, right? It's just the lines.
Yes, that is this line. I'm trying to make it thicker. Okay, Daniela, what did you say? Can't do anything in this until the absolute value bars are gone. You can't get rid of the 2w until the absolute values are gone, but we can drop it, and when we do that, what happens? What do we do?
You do the positive.
And the negative.
I think you can just make it longer.
And then you add 4.
Then we can add 4. What are you talking about?
I like the lines.
Okay, so then now we can add the 4. And then, so with these problems, if you only put the positive, solve it, and just put positive, negative, whatever you get at the end of that, that will not give you the 2 correct answers. You have to do this at the beginning, otherwise your answers will not match up and will not be correct. What would our 2 solutions be? In order, negative 7, 11.
Wait, why did you write 2w equals negative 6?
Because we added 4 here. Other questions there? For 16, what do we think should be the first step? We should be getting rid of whatever is adding or subtracting first before we touch anything that's being multiplied. Because if you start dividing or multiplying wouldn't be as bad. But here, if you were dividing, then you have to do that to every piece. Yes.
How would you get -7?
Negative 14 divided by 2.
Oh my bad, I was looking at the other side.
It's okay. Alright, so add 24 on both sides. What's our next step? Good. Zach. By doing what? Multiplying by what? 2 over 3. Yes. So in this case, I could divide both of these by 3/2, but you don't want fractions everywhere. So instead of doing that, take it, flip it, do the reciprocal, and multiply on both sides. So that these two fractions completely cancel. The 3's here would cancel, just leaving 2.
So every time you have a fraction, you have to flip it?
If you are solving, if it's part of the, if dividing would be the next step to usually get that by itself, yes. If you're just distributing, no. So it depends. Cassie, you were gonna say.
It's always going to cancel out if you flip it.
If you flip it, yes. When you multiply it, yes.
Would I be like able to divide it instead if I didn't mind?
So right now, yes, but moving forward, I wouldn't keep doing that because we're going to get into complex things where that would not be ideal. Okay.
You just flipped it.
Okay. What's our next step? Drop the absolute value bars first. And
Plus 4.
okay, so this will be 4r equals 6. We're going to end up with a fraction. But we're missing something. The -2. So when you do this, also make your second equation at the same time. What would your two fractions be?
Wait, why is it negative 2?
Here, because we made our two equations. One's always positive, one's always negative.
Oh, yeah.
Why is that side -6?
This side?
Yeah.
Because -2 plus 4 is 6. -2 plus 4 is 2. Okay. What are those two fractions? So they should both be positive because we have 2 divided by 4 and 6 divided by 4. What was that last part? Sorry.
6 divided by 2 is 3.
And this would be 6 divided by 4. Well, so it's going to be 1/2 and 2. Yes. And 6 divided by 4 1/2. 1/1. Leave it as a mixed improper fraction. 3/2. 3/2. So those of you that got 2, you're dividing by 4, not 2. So you shouldn't have gotten a whole number there. Now these are nice enough fractions you could have put decimals, 0.5 and 1.5. But if they're not, leave them as fractions. If you're not sure which one is bigger, divide them so that you can actually see the number, the decimal. What questions do we have there? Do you have any questions about that one? Okay. Then we have some special case solutions. They're not. That's the algebra thing. So for this, if you get some isolated absolute value expression that starts off equaling a negative, you can't do anything with it. It's no solution. So if we look back to some of our previous ones, this did equal a negative, but as we started to isolate it, it became a positive. So if you can solve it and that number becomes a positive, keep going. But if you isolate it and you get to this point, and this number is a negative, you can no longer solve it. It's no solution. Some of them won't look like it's no solution until you start to solve it, and vice versa. So in this one, I would do what to start solving this? And then as I start to solve this, when I divide, this becomes that negative. I can no longer solve this. That's your stopping point. I can't make this into a positive and negative because absolute value can't equal a negative.
Why should you define it?
Because these are multiplying. They're next to each other. So to undo that, we would divide. So anytime you have isolated the absolute value bars and it equals a negative, you're going to get no solution. You cannot do that. That has expressions, isolated absolute value expressions, and equal a negative number. Okay, I'm going to show you how to check this in Desmos and where the button is on the calculator. I did just get a new poster for absolute value, but I haven't sent it yet. So on the calculator, just like you would put numbers in to check, you would do the same thing for the calculator. Here we go. So let's say I was checking 15 and I wanted to see is 1/2 and 3/2 are 1/2 and 3/2 my actual answers. I would put this back into the R and I would solve that, and it should equal the same thing on both sides. So should 3/2. So you can check that just like normal. You can use your calculator for that. If you're putting in the absolute value bars, there are two ways to get there. One is by hitting alpha. Everyone do that. Window. Alpha window. So alpha window is at the very top.
It's the green button.
Alpha green button window at the very top is at the very top. You may not see this, but you should see ABS, which is your absolute value. Yes. Or one. Yes. Okay. The other place, if you forget, is second. So the blue button, 0, which is your catalog that has every button on the calculator in it. But that's where you could also find it. Second, 0 or alpha window. Wait, which window is this? Lock. In Desmos, We're almost done. In Desmos, if you are checking this, if you put in the entire equation, you'll get your two answers, but you can't click on these like you could before. You can zoom in though, and that should tell you what those solutions are. In your keyboard, while you're typing this absolute value bar A, those are your absolute value bars. You can also type in the letters ABS. It will pop up. Or you can use their specific ones on a keyboard if you're on your computer. If you were to put in something that's no solution, I'm not going to start right here. So that should tell you that's going to be no solution. Okay? Questions on how to check it in Desmos? Okay. So for the rest of the class, I want you guys working on these things. There is a Delta Math on this. That's due next week. I want you to try this first while this is still fresh in your mind. Then after that, if you haven't done the 3 Delta Maths that are due today, multi-step equations, real world problems, multi-step equations with variables on both sides, then you could do those. Or you could do retake work after you've done the absolute values equations Delta Math. You guys can move around, use your notes with each other.